All right, here we go. Backside of the 1.1-6 notes, and same idea. These ones may not look like quadratic equations because they're not right now. Right now they're rational expressions, but we're going to work with them until we get them into being some quadratic equations. So on the first one here, we've got a denominator of z and of z minus 3. And remember, fractions, they're just division problems. So if we have divided by z here, how do we get rid of it? Well, we multiply both sides by z. Likewise, if I want to get rid of the denominator of z minus 3, I want to get rid of it being divided by z minus 3, and then multiply both sides by z minus 3. All right, and now that we're doing that, again, multiplying both sides by the same thing, so these are still equal. Now we can continue on the problem. So what is z divided by z? Well, that's just 1. And so we're left with 4 times z minus 3, or 4z minus 12 is equal to, now here on the other side, z minus 3, that quantity divided by the quantity z minus 3, that's also 1. And we're left with 3z times z, which is 3z squared. All right, from here we'll subtract 4z and add 12 to both sides, so minus 4z and plus 12. That gives us 0 equals 3z squared minus 4z plus 12. And so if you want to look at it, see if you can factor it, so on and so forth, go ahead and pause. I would run through, see if you what you get with your discriminant. And again, if it's a perfect square, then it's factorable. Okay, so hopefully you tried that and you paused the video and came on back. This one is not factorable. We'll have to use the quadratic formula. Or you could do completing the square, but quadratic formula is probably going to be easier here. And so we're going to end up with x equals negative b, which is our a, b, and c values are 3, negative 4, and 12. So negative b over 2 times a, over 2 times a, which is 3, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a times c, also divided by 2 times a. And I've got all that here, and actually I'm going to come over to the side over here to simplify some of that out. So negative 4 over 6, that's going to simplify down to a positive 2/3. So x is equal to 2/3 plus or minus. Now here that all the radicand here, that's going to simplify down to negative 4 squared. That's the square root of 16 minus, well, 4 times 3, that's 12, and times another 12, so minus 144. And I subtract those out, and I get the square root of negative 128, which is going to be I, that's the negative, I'm going to factor that out, times the square root of, well, 128, let's see, that's going to be 2 times 64. So the square root of 2 times 64, and the square root of 64 is 8. So this all turns into 8i root 2. So plus 8i root 2 over 6. And then lastly, that also will simplify down for us a little bit. 8 divided by 6, that's going to be 4/3. So then our answer is 2/3 plus or minus 4i root 2 divided by 3. And now we continue on with f. And as we look at f, it's going to be very similar to the one we just did, just a little more complicated, but the same idea, same process is what we're going to do here. So x squared minus x minus 6, that's going to factor down to x minus 3 and x plus 2. And that's going to be useful because if we look at the other denominator, there's also an x minus 3. And so as we multiply both sides to get rid of our denominators, we don't need to multiply by x minus 3 twice. We just need to multiply by it once. So multiply both sides by x minus 3 and x plus 2. Over here, x minus 3 and x plus 2. Now for the left-hand side, x minus 3 and x plus 2 is what our denominator is. So it's actually both will cancel out, and we're left with 1, or I guess it cancels out with however you want to think of that there. But we're left with 1 times x plus 2, so x plus 2 equals, over here, and the denominator on the 3 is just 1, so nothing cancels out. So we have 3 times x minus 3 times x plus 2, but I don't need to worry about working that back out because it just came from over here. It was the x squared minus x minus 6, so 3 times that. So 3 times x squared minus x minus 6, which again is just that multiplied back out, minus there. And over here, the x minus 3 divided by x minus 3, that's 1, leaving us with 4 times x plus 2. Alright, let's go ahead and simplify that. Lots to simplify. Right now I'm not even going to subtract anything from both sides. I'm just cleaning it up a bit. So 3x squared minus 3x minus 18 minus 4x minus 8 and 4x. And continue to clean that up. So x plus 2 is equal to 3x squared. And now we have minus 3x, or negative 3x, and negative 4x, that's negative 7x, and negative 18 and negative 8, that's negative 26. Alright, now we'll worry about the subtracting x from each side and subtracting 2 from each side. So finally, after all that cleanup, we're down to 0 equals 3x squared minus 8x and minus 28. Now again, you might want to pause the video and try factoring that on your own. See if your discriminant becomes up as a perfect square. And hopefully you've paused the video and you tried that and you found out that it did. Over here I wrote down, here's the work I had for it. I knew that the numbers were going to multiply. 3 times negative 28, that gave you negative 84. Again, 3 times negative 28. And so looking for two numbers that multiply to give us that, but add to give us negative 8, our b value back over here. And for me, I like to have a very systematic way of going about it. And so going through, if you're multiplying to give you a negative, you know one number is positive and one is negative. And if they add to give you a negative, you know that the negative one is bigger. So I started with 1, and I said 1 times what negative number would give me negative 84, and saw that they didn't add up, and kept on going until I got positive 6 and negative 14, and those are both x respectively. So whether you use the box method or whether you use grouping, so then we'll have 3x squared, 0 equals 3x squared plus 6x minus 14x minus 8, or minus 28, sorry, minus 28. All we're doing right there is splitting this up into two different pieces to see what if we had, when we have our factors, when we multiply out, what's the middle two terms going to be? We just broke that apart from negative 8x into these two pieces. So if you're factoring by grouping, we've got 0 equals, well, 3x. We factor out of those, leaving us with x plus 2. And over here, minus, let's see, 14 factors out of each of these, and leaves us with the exact same factor inside of here, which is what we need. So if I factor out a negative 14, I get x plus 2 again, meaning our factors are going to be 0 equals 3x minus 14 and x plus 2. If you use the box method, that's perfectly okay as well. Using that, we'll get the answers of, or the solutions rather, of x equals -2, and let's see, that's going to be 3x minus 14 equals 0. Add 14 divided by 3, so 14 thirds. Now, the problem with our answers right here now is that if we thought about actually plugging these back in, if we plug -2 back into right here, we'll get 0 in the denominator. So -2 squared, that's 4, minus 2, minus -2, that's 6, and then minus 6 is 0. So we'd end with 0 in the denominator if 2 is in here. So last video I just said it was a false answer, but to be more specific, they're called extraneous solutions. They're solutions that when you get them, you didn't do any math incorrect. They're just false answers. So -2 is an extraneous solution. Your only answer here is x equals 14 thirds. All right, hope that helped.